Welcome everybody, this is Mr. Fugu and you're watching Mr. Fugu Data Science. Today we're doing a tutorial for parsing addresses using regular expressions in Python. As always, the code will be provided on my GitHub, which is Mr. Fugu Data Science. If you like this and would like to watch any other videos, feel free, Mr. Fugu Data Science. I created this tutorial because it's regular expressions in general are difficult, let alone parsing addresses. I provided the documentation for the regular expressions that are used in Python, and you could read through this. I feel it's a very valuable tool to get started with. These little tables will be your kind of go-to in the beginning to get an idea of what's going on, and then here's some little tips and tricks that you'll be using within this tutorial. Not all of them, but most of them. We will import pandas, RE, and faker. I decided to create fake personal data today. It's fairly similar to real postal addresses in the United States. I created 500 entries. I just made up a seed so I could replicate this data. I would like to show you what these data look like. So when you create what's called a profile in Faker, it generates this. I think it's like 13 columns, but it's like a job, a company, a fake social, residence, your latitude, longitude, for some reason a blood type, if you have a website, username, name, your gender, and then address, and then your email for mailing people, and a birthday. But today we're using these strings of addresses. Alright, now I split one line just so you get an idea. So you have like your general street number, and then this would be basically whatever your street name is. For instance, this is a suite with the suite number. This is your city, but in this case it's in the eastern part of whatever the city is, your state, and your zip code. This will be called a post directional. If you had something here in front, right here, it would have been like south, north, whatever the street is, that would be a pre-directional. Alright? Now, what I'm doing is using the re.sub method, changing anything that's just box and representing it as P.O. box to make it a more standard formatting, such as that of the Postal Service. So we update our P.O. box with this, and let's find one. There it is right here. There's the updated format. Then to handle the P.O. boxes, there's a few things. For instance, foreign military P.O. boxes will always have a PSC, and then somewhere inside of it you'll have an APO or FPO. And then there's the other regular P.O. box types. And I wanted to test out three different methods that we can do using re.compile, where we're using the \b, which is a word boundary, where we're looking for a P.O. box, and we're taking everything after the P.O. box. Alright, so we're matching, but we're not capturing. That's what this is doing. Match, but don't capture the P.O. box, and this take everything after at least one time. Okay, then this take everything before a P.O. box. So we say this look for everything, let's except for a new line at least one time, and this take it. And we're doing a look ahead, where we're saying let's match a suffix but exclude it from our parsing. Then after that, let's find everything in the sentence. If it includes a P.O. box, let's take that sentence. So we do our word boundary again, and we're looking for everything that includes. We're saying let's take everything, and let's take all of it, including the P.O. box, and if it's at least one time, let's look for the new space, the word, and let's take those. Okay, so we run that, and this is what it looks like if we were only taking this one, which is matching the whole string and splitting it. All right, excuse me. Then we can look and say, all right, what does it look like if we're taking everything after the fact? So we can put that here. Can match everything after the fact. What's that look like? Okay. So we're taking we're taking everything and hold on. So where's the P.O. box? P.O. box. We're taking everything that has P.O. box and directly after it. So that's the P.O. box number. Okay, so we're taking everything and including the P.O. box number and stopping at the new line. I should have paid attention. And then this one should just take everything before it. So it should stop before this. Okay, there we go. That stops before that. All right, cool. So put it back to where it was. So we can look at the whole sentence, which is what we're ideally looking at, unless you wanted to parse it a different way. So now let's find strings that have apartments or suites in this data. If it was anything extra, you could just use an OR and type it in. If it had a unit number like this or any other qualifiers. So I'm creating a string of apartments and suites, which would be my empty list that we're going to store our data. So we're taking our updated P.O. box list of strings, and we're looking for a word boundary where we're doing a look ahead, trying to find an apartment or a suite, and we're going to take anything that occurs at least once. So I created something where we're taking everything before the suite. Also, so we'll print that off here. Is it printed off? Yeah. So that's what this looks like. We're printing off the whole string that includes that, but this is the string that stops at the space before you get to the apartment. So you say, all right, let me find the word boundary where we're looking for the apartment. We're doing a look ahead, but we're not taking anything after it. We're just verifying that this is there and taking it beforehand, before that space. Okay, so now after we have that, we will say let's create a list where we don't have any P.O. boxes. So we're taking our re.compile, and we're using this from earlier where we're taking the whole string that includes a P.O. box. So you're looking for a word boundary here where we're saying let's take this group by, which is this P.O. box, and then let's basically take anything that occurs that's separated by a space and any words that occur at least one time, and let's grab those. And if that occurs, just ignore it, because everything else will be what we're looking for, which has no P.O. boxes, which is here. So there's no P.O. boxes here. You do have your military address, if you pay attention. So let's get rid of our military addresses. Well, how do we handle that? Okay, let's use our trusty old re.compile again and look for the beginning of our string containing digits where you have a range of digits which can be either 1 or all the way up to 6. I've never seen 6, but I included it just to be safe. And I said, then let's take everything that happens after the fact, where we have a new line, we have words, and it's occurring at least one time. So we iterate through that, and we're looking to match words for a P.O. box, which will say I, while I'm iterating, and I'm storing that and calling it store addresses. And that looks like this. And anything else that's not a part of this will be appended to the military addresses, which is this, which is a very easy thing to parse. So now that we have this, we can move on to parsing the actual addresses. And I say, well, there's a few things going on. I have a digit that I need to take out of it. I have a cardinal direction, a street name, possible post direction. Maybe there's a suite number, a unit number, an apartment, and then city, state, zip. And then why did I leave these empty? Well, because we're going to get to those below. So I made a little example and said, let me take one of our little entry strings and look for just the digits for the street number. That's really easy to find, because we say if the string starts with a character set, which is our brackets of digits, and it occurs at least once, just grab it. Then, if by chance we had a cardinal direction, you know, like a north, south, east, west, just take that from it. And you say, oh no, this is complicated because it's after the digit, it's with a space, and then there's a new boundary word you have to look at, and it's like, oh my gosh, this is going to get crazy. So you say, all right, let's look at this. And you say, let's start with a digit, then if there's at least one, separated by a space, and then in that you have a grouping where the grouping starts with an S, and then you can have the S separated by a space, separated by a, or separated by a dot, or it's just a O, or it's an, you know, OUTH. Then you could have a character set, so then it could be like a south, east, west, you know, whatever. You don't need that north for this one. And it just expands on, and you have to do that for all of them. And then you could create a flag where you're ignoring the case, uppercase or lowercase, so you're just looking at the string. And then I create that, and I say, okay, let's look at this goofy thing, right? And we parsed out just the S and the W. And then what happens if it was S.SW? Oh, okay. What about if it was like this? SWS, or S period W period. Well, that works too. So it looks like this is kind of catching them, right? Okay. So this looks plausible, but it's really big. It's ugly. It's going to take up a lot of time just to start parsing through this, especially if you had a lot of data. So I said, all right, let me start looking for something else I could start doing. Hold on. Why isn't this working? Okay, so what's going on here? Okay, so I messed with something and it doesn't work. Never mind this then, I suppose. Then we can say, let's look at oh, this is getting me curious. Live coding and looking at this. No, I don't want to do that right now. Then we'll say, all right, let's look for the apartments next and take those out. But then I have a problem. I'm doing a look ahead where I'm looking for the apartment, then I'm looking for a word, and then it's separated by anything not as a space. So I say, okay, how do I deal with this goofy thing? That's only printing out the apartment, and it's giving me the pleasure of seeing the dot, which came from here. So then I need to create a word boundary, and then I do a look ahead, but I want to actually capture the data. So then you have to use the look ahead, but put it with a parenthesis. See, this one was attached directly to the word you're looking at. This one is saying, let's do a look ahead, but let's actually capture all of the data. Where we're saying, let's look at the capital S, which is, I think it's everything not as a space, and then let's look at a space and then any words let appear at least once. And that's what happens here. And you say, well, what's with this indexing? Well, if you don't do the indexing, it prints out like this for both. But I know from looking at all of them, I could use this indexing and print out my address, my apartment number. Okay, that looks good. Now I need to look at the state and the zip code. So then we're doing a positive look behind. Positive look behind to find our state and zip code. So you have this string, and you could split it on the new line, which starts here, and then you could start parsing your data if that's how you want to do it. And then you'd have in this one, you'd have city. You could pluck that off first, and then you could create a new string and separate it by a comma. And then you could take these out individually. Just depends on how you want to set this up. Or we can do a positive look behind and stop where we find the comma, which would have been right before this space, and take care of that. Okay. So I can't do that, huh? I can't do, because that's weird. So I was trying to get rid of the extra space right here. So I'll take care of that later. Now, if you don't do this look behind, and you just say, all right, let's just do a look ahead and look at this comma, well, it includes a little comma with you, and that's not really what you want. Unless for some goofy reason maybe you do, but I don't know why. Then we could start looking at our cities, and our cities are stopping at that comma point. So we say, let's verify what's really going on. So we say, all right, here's the comma, and our city is right before the comma in the middle of our new line. Okay. So we want to find everything except for the new lines. Let it cruise at least once, and let's grab it. And let's do a look forward. A look. A look forward, look ahead, and find that comma. And that's where we take our city. But there's a problem. What if your city has a north, an east, a south? Well, that's your post directional that you need to take care of according to the Postal Service. So we got to take that into consideration now. So this is our first, for our cities. The second step will be taking out your north, south, east, west. So we're using the great re.sub method, where you put what you want to use, or no. If we have that, let's put a replacement of an empty string, and let's iterate through there, And now, if you look, we took care of all the north and the south, and it's no more. Okay, well that's fine and dandy. And I use this to strip the extra space that was to the left of it, that would have been in here with it gone. Okay, well that's good. Now we have our state and our zip codes. So we need to do a positive look behind where we're finding anything up until we find our comma and we grab it. And then we need to loop through this again. So what happens is this. So you say state zip looks like this. So this is what it looks like. You still have the space and you have a space here. From the next step, you take care of all the extra white space. You replace and you strip it. You replace the extra space that you have here and you put a comma, and then you split that comma. And that's what it ends up with here. And then this is easy for you to take out what items you want. So we could say, okay, find that. Now we could create a data frame. You could iterate through. You could do whatever you want. So you have easy access to state and zip code now. And then if you're doing a goofy way where you wanted to do all of this, all this nonsense to try to capture south and west and east and different variations of, you know, east, south, north. You have all this goofy stuff like this, and then you would have to basically extract out the words you want and take away everything else and then just keep the empty. If it doesn't include this, then you take an empty string, so then you maintain your count for if you're creating a data frame. So I said, well, that's just nonsense. I don't want to go through all this regular expression junk. That's just too much work. I did it. I don't want to do it again. So we could create our post directional a little differently. So let's look at what O was. Built-in function, not iterable. What's going on here? Why is this getting called? Oh, it's not letting me do a set here anymore. Why? Oh, hold on. There we are. Use my brain sometimes. I was using these to play with as my small set, so then I could figure out how this works. So basically, this is what I did. Create something that's really small so you can test this and figure out how it works. And that's how I figured out this. And then I said, I don't need this anymore. I could do these. And that's what happens. Perfect. So here's our original cities, where we have our good old north and our good old east and all that stuff. And then we have to iterate through that, and we're extending this, so we're flattening out the list, and then we're splitting on the spaces. And then we have to iterate through this list now and then do a set difference. So we're comparing one of these with this. And then if it has something in common, you append it. If not, you just put an empty list, so you maintain your length, your list length. So that was an easier way to do that instead of all this junk. Then I wanted to do a large iteration instead of the practice from up above and find the apartments and suites. And so I took all of the code that we used before, where we did a word boundary, we did a look ahead, but we wanted to capture everything within the look ahead. Then if that is there, append it. Else, empty string. Then let's see what this looks like. So that's what it looks like. But we need to get rid of these like last time. And that's why we're iterating through it again to take care of that. And so we said, okay, if we have an empty list, append the empty list. Else, append the first element in each one of those, which is this. So now we have an apartment. But what about our military addresses? Well, I didn't parse those. Why not? Well, because those are super simple for two reasons. We can split everything on the new line. And then after you have the new line, then you'll have two separate strings. And then you could split those strings again by a space and make a comma separator. And then you have all of these separated by commas. So be each one of these separated as a comma. And then you could just pluck out all the independent information you want. That's the end of this video, and I would like to say thank you for watching. Please throw me a like if you thought this was valuable content, or at least, helped you out in any way. And don't forget to subscribe. Have a good day. See you in the next video. Bye.